you remember the last time you went shopping online? Remember all the pictures of clothes, books, and electronics that you looked at? What if I tell you that those images weren't really for you? What if those pants you were looking at were really detailed blueprints of military installments? You would never know, right? This is the nature of steganography. Steganography is science of hiding information from plain sight. Secret communication is very important because if your message is important and if you do not want others to know about your message, then you use different kind of techniques to hide your message from third person. And steganography is one such technique. However, criminals and terrorist organizations are using this for their own purpose. So understanding how to hide data using steganography and prevent the data from being misused will be very helpful. However, to talk about steganography, we should consider its predecessor, cryptography, which is science of writing its secret codes. Basically, cryptography makes messages meaningless to the casual reader by encrypting the data using set of rules which are known to both sender and receiver. Only the intended receiver with the decryption key can extract the actual message. Thus, when an attacker discovers the message, it is still difficult for him to get the secret message. If cryptography is a strong way to encrypt and secure a communication, then why do we need a new technique? Answer is very simple. When we are using any cryptography technique, we need to send a secret key and third person can easily judge that some secret kind of communication is going on. In simple terms, cryptography does not try to hide the fact that secret message is being sent. This is where steganography comes into picture. The main reason of using steganography is that you are hiding your secret message behind an ordinary file. No one will suspect the fact that a communication or some sort of secret message is being sent. People will generally think it is an ordinary file and your secret message will go without any suspicion. Unlike cryptography, which conceals the content of a secret message, steganography conceals the very fact that message is being communicated. So if I have to define steganography, it is an ancient art of covering messages in a secret way such that only the sender and the receiver knows the presence of the message. Well, now if you're thinking steganography is a brand new method, then you are mistaken. Steganography is an ancient practice. The word steganography is derived from Greek word steganos, meaning hidden or concealed, and graphen, which means writing or drawing. Before moving further, let's get a glimpse of how steganography evolved from past. The concept of steganography was first introduced in 1499, but the idea itself has existed since ancient times. There are stories of a method being used in Roman Empire whereby a slave choosing to convey a secret message had his scalp shaved clean and a message was tattooed onto his skin. When the messenger's hair grew back, he was dispatched on a secret mission. On the other end, the receiver shaved the messenger's scalp again and read the secret message. Well, that was one way of doing it. Demaratus, the king of Sparta, sent a secret message on tablet covered with wax. When it was received at the other end, the wax was scraped off to recover the message. Another oldest and the most fascinating and common way to hide message is to use invisible inks. The actual message can be made visible if document was heated gently. Next came the null cipher. Null cipher refers to the method of encrypting where plain text is mixed with actual message. Next was hiding data in the images. Microdots were used to conceal a message. A microdot is a simple text or an image which is reduced in size to hide its contents. And this microdot or the images or the text which are present in a microdot are then read using magnifiers. Apart from these techniques, there were others as well, like spread spectrum, semograms, etc. So like I said earlier, steganography is an ancient practice. The majority of today's steganographic systems use multimedia objects like image, audio, video, etc. as cover media. Well, if you don't know what I mean when I say cover media, don't worry about it. You will know more about it as we progress through this session. But for now, cover media is a place where you actually store your hidden information or you store your secret information. So based on the type of cover media, steganography is divided into multiple types. To begin with, we have text steganography. Text steganography is hiding information inside the text files. It involves things like changing the format of existing text, changing words within a text, generating random character sequences, or using some sort of context-free grammar to generate readable text. Well, there are different methods to hide data in text. Some of the popular ones include format-based method, random and statistical generation, linguistic method. Moving on, we have image steganography. This is nothing but hiding data in an image. It's one of the most popular way of hiding data because in image, there are huge number of bits present in digital representation. So it's easy to store or hide data in an image. There are a lot of ways to hide your information inside an image. Common approach includes LSP steganography, which we'll be discussing in detail later. And then there is masking and filtering, some sort of encryption techniques, and many others. Moving on, audio steganography. It sounds according to its name. In audio steganography, a secret message is embedded into an audio signal, which alters the binary sequence of corresponding audio file. Then there is video steganography. In video steganography, you can hide any kind of data in digital video format. The advantage of this type of steganography is that large amount of data can be hidden very easily. You can think of it as combination of image steganography and audio steganography. Well, there are two classes of video steganography. One is embedding data in uncompressed raw video and then compressing it later. Other one is embedding data directly into compressed data stream. And next there is network steganography. Like it sounds, it's a technique of embedding information within network control protocols like TCP, UDP, ICMP, and many others. For example, you can hide information in the header of an TCP/IP packet in some fields that are either optional or not important. And finally, there's email steganography. It's not a very well-known type, but anyway, email that contains the files embedded within hidden information using steganography can be very difficult to detect as well as read. Now that we have learned of different types of steganography, let's take a look at few features that a steganographic technique must and should possess. I'm sure you can see an image of an adorable and cute kitten on the screen, right? Well, that's our cover image or the file where we store our secret data. So the first feature that any steganographic technique must possess is transparency. It's an important feature. Each cover media, it can be image or audio or video, has certain information hiding capacity. If more information or data is hidden inside the cover, then it will result in degradation of cover media. As you can see, the stego image or our final image after hiding data inside our cover image is not proper or exactly similar to our original image, right? So there's some sort of distortion. So if attacker notices this distortion, then our steganographic technique fails and there is possibility that our original message can be extracted and damaged by attacker. Well, that's the first feature. Next feature is robustness. Robustness is the ability of hidden message to remain undamaged even if the stego media undergoes some sort of transformation like cropping or scaling and blurring or linear and non-linear filtering or some sort of hindrance. So we have to make sure that technique in any way doesn't affect our secret message. And the last property, tamper resistance. This is one of the most important feature because if attacker is successful in destroying the steganographic technique, then the tamper-resistant property makes it difficult for the attacker to alter or damage the original data. While you can think of it as a last step that as a sender you can do to protect your data from other people. Okay, so till now we have covered what steganography is, a bit about its history and its types. Now let's go through a basic steganographic model. Well, it's pretty simple concept. But before we start, we should be aware of few technical terms that I was using earlier and which I said I'll explain later. So here we go. We have something called cover object or cover file. This is the file that we will use to hide the information. It could be an image or a video or an audio or network or the different types which we discussed earlier. And then there is our secret message. As you know, this is the secret information that we want to hide into cover object. And sometimes you also have something called stego key. And I'll explain you what that is when we encounter it. So let's get started then. So there is a steganographic encoder, which uses some sort of steganographic method or function to embed the secret message, which is represented by M, into our cover object or cover file X. So as you can see, there's a function which takes X, which is our cover file, M that is secret message, and another input that's K. Like I said, K is nothing but key or stego key. It is a key to embed data in a cover and extract data from the stego medium. Well, it's optional. Using a key provides extra security, that is all. So basically our steganographic encoder method or function takes this cover image, secret message and key as an input and embeds our secret message into cover object. Embedding process generates a stego object and the stego object looks exactly like our cover object. Now, this Stigo object is sent to receiver through the network without any encryption here. So this is where our steganographic encoding process ends. Now, if on the other end, receiver wants to extract the secret message, all he has to do is feed the Stigo object into steganographic decoder, which also takes key as one of its input, and then as a result, he gets secret message which was intended for him. So like I said, it's a very simple process, right? So if I summarize, you have your cover file, which could be image, audio, or anything. And then you have your secret message. Both of them, along with the key, if you want, are fed into steganographic encoder. As a result, you get your Stigo object, which looks exactly same as cover object. And this Stigo object is sent to receiver through secure communication channel with or without encryption. On the other end, if receiver wants to extract the secret data, he feeds this Stigo object into steganographic decoder and he gets cover object and secret message as an output. So this is how steganography actually works. Well, if I want to make this process more secure, I can add one more step, which is encryption. Let's see how to do that. So like I said, there's a sender. Before actually feeding the secret information into steganographic encoder, he encrypts this secret message along with an encryption key. As a result, he gets a ciphertext, or like we discussed when we were discussing cryptography, the meaningless text or the ciphertext. This ciphertext along with steganographic key or Stigo key and cover file is fed into steganographic encoder. Embedding process generates a Stigo object, and this is where our encoding process ends. This Stigo object, which looks exactly like our cover object, is sent to receiver using a secure communication channel. Now on the other end, if the receiver wants to extract the secret message, he feeds this Stigo object along with Stigo key into steganographic decoder. As a result, he gets a ciphertext, and to decrypt the data, he feeds this ciphertext and the key, that's decryption key, into decryption algorithm. And as a result, he gets the secret message which was intended for him through the sender. So there you go, guys. That's simple. So like I said earlier, we discussed the most simple process. If you want to make it more secure, you can include encryption as well. So basically, any type of steganographic method or technique works this way. It's just that the type of algorithm they use, or the encryption algorithm, or the technique they use to embed data into an image or a video, or it could be anything that's cover object, is different. So guys, till now we've learned about what steganography is and how a steganographic technique actually works. It's time that we should learn about one of the most popular steganographic technique, which is LSP steganography. If you remember, earlier we talked about image steganography, where we hide secret data inside an image. Well, one of the popular technique to hide secret message inside an image is LSB steganography, or least significant bit steganography. Now, before we jump into what LSB steganography is, let's take a look at a few basic concepts. On the screen, I have an image. To be more precise, let's call it a digital image. Every digital image is a finite set of digital values called pixels. You have probably heard the term before and generally know that pixels make up an image. Pixel is actually short for picture element. Well, you can think of them as dots of illumination, typically so small that you're unable to see them. Thousands or even millions of individual pixels together make up an image. So each pixel can be one color at a time. However, pixels are so small that often blend together to form new colors. In this session, we will work with RGB color model. The RGB color model is an additive color model in which red, green, and blue light are combined together in different ways to reproduce a broad array of colors. And each of these can be represented using a binary code. So like I said, I have three values, which are RGB, that's red, green, and blue. And each of this value is represented in a binary code. So by mixing the 8-bit binary red, green, and blue values, pixel can be any color. And the color is usually determined by number of bits used to represent it. Well, in this case, we are using 8 bits. So we can display for about 250 colors. Moving on, when we are working with binary values, we have more significant bits and less significant bits. The leftmost bit is the most significant bit. On the other hand, rightmost bit is the less significant bit. Now, if we change the leftmost bits, that is most significant bit, it will have a large impact on final value. For example, let's say I have 255 and its binary representation, which is 8 ones in 8-bit representation. Now, if we change the leftmost bit from 1 to 0, the decimal value will change from 255 to 127. As you can see, the amount of change is very huge here. It has made a large impact on final value. On the other hand, The rightmost bit is the less significant bit. Now if I change the rightmost bit, it will have less impact on final value. For example, if we change the leftmost bit, which is 1, to 0, it will change the decimal value from 255 to 254. And you can note that the change is about 0.002%, which is very less when compared to most significant bit. So the point I want to state here is that if we change most significant bit or MSB, it will have larger impact on final value. But if we change LSB, the impact on final value is very less. This very point is made use by LSB steganography. So in this method, which is LSB steganography, least significant bit of an image or of a pixel in an image is replaced with a bit of a secret image. The result of this process alters the original output very slightly. So your cover image and your Stego image, that's your final result, after hiding the data, look exactly same without any difference. This technique works very good for image, audio, and video steganography. Well, let's consider a simple example. Suppose we want to insert letter A into an image. The binary representation of A is 1 followed by 5 zeros and again 1. Now, like I said earlier, we are using RGB color model here. So, and I'm using 8 bits to represent each of these values, which is red, green, and blue. So, I'll be needing about 3 consecutive pixels. That's about 9 bytes to replace all the least significant bits by the bits of the letter A. Well, don't worry about it. You'll understand once you see the next image that I show you on the screen. So like I said, I'm considering 3 pixels, which is about 9 bytes. So these are the pixels before insertion. I've picked like random pixels. So as you can see, I have 3 pixels, 1, 2, 3, and 9. So totally 9 bytes I have here. And now if we replace the last bit or LSB for each byte with a bit from binary representation of A, what we get is this. So as you can see, I have replaced the 0 with this 1 here. So as you can see, 0 is replaced with 1. And then I have 5 zeros. 0, 0, like 5 zeros followed by 1, 1, which is already 1, so I'm not replacing anything here. So as you can see, all the color bits have been replaced here. So once you are done with replacing, you'll find that the final result or the Stego image is very much identical to your actual image. That's your cover object. On an average, LSB requires that only half of the bits in the image can be changed. As you can see, I've like left 3 or 4 bits unchanged here. For example, this one, and the 0 here. The 0 in the first line, in the last line, I have 2 ones left without changing it. So if need required, you can hide data in the least and the second least significant bits as well. And still, the human eye would not be able to discern it. So guys, that's all about least significant bit steganography. Well, that's the concept. So to summarize, every pixel can be represented using different color models. Well, in this demo, I've used RGB color model, and each of these values are represented using 8 bits. While you can use a different number of bits as well. And this number of bits used usually determine the color which pixel displays. Like I said, we have used 8 bits here. And in a binary format, we have least significant bit and most significant bit. Like I said, changing most significant bit makes more changes to our final value. But that does not happen when we change the least significant bit. So we made use of that point. So basically, the least significant bit steganography make uses of the fact that changing LSB doesn't make much change to our actual image. So it replaces the LSBs in the cover object by the binary bits of secret message. So there you go, guys. Now you know the theory part of the concept. It's time to perform a small demo. In this demo, we'll see how to use the concept of LSB steganography and hide secret text in an image. So here are the steps involved. First, to encode the text into image, the program loads an image and looks or considers each pixel hexadecimal's value. Then the program asks you for the secret text and converts it into its binary form. And then one by one, it stores the secret message bits into LSB of image pixels, which is our blue value bits of RGB model. After the message is embedded into an image, program adds delimiter to the end to determine when the text ends. So here ends the encoding process. Suppose you want to retrieve the data, then the program extracts all the zeros and ones from the Stego image until delimiter is found, and there goes our secret message. So these are the steps we'll be performing in the program. So guys, this is what our program does. Well, to summarize, it takes our image, it converts that into hexadecimal values, it takes our secret text and converts it into its binary value, then replaces the LSB of cover image with the bits of secret message. Once it does that, it adds some delimiter at the end so that we know that this is where the text ended. So this is how encoding is done. Suppose you want to retrieve the message, all you have to do is extract zeros and ones from the Stego object and convert the binary form into string format. That way you can get your secret message. or the receiver can extract the secret message. Well, I'm using the code which I found in GitHub. And suppose if you guys want to experiment as well, please do post your email IDs in the comment section below and we'll get back to you with the code. Now let's get started with the demo. So guys, I'll be using my Ubuntu system here. So as you can see, I have a code. Let me show it to you guys. I have code here and I have certain images of different formats. I have one of JPG and one of PNG as well. Okay, let me delete this file, move to trash. So going back to terminal, let me show you guys the code first. The file name was hide.py. Okay, I think I've misspelled it wrong anyway. Let me just check it anyway. It's HID. Silly mistake, hide.py. Here we go, guys. I already have code because I've already extracted it from Git and I'm using it here. So I'm just going to explain you the basic concept of how this code works actually. So like I said, we're going to convert our image into its hexadecimal format. So I have a code which converts RGB values to hexadecimal values. Before that, since we're using images here, we need to import certain libraries. We need Python library image or PIL, which is below. Well, if you're using Windows operating system, you need to separately download it. But if in Ubuntu, it comes by default. And suppose if it doesn't work, let me go back. Well, if it doesn't work, all you have to do is make sure you have Python 3 version installed. For that, check Python 3 version and make sure you have pip installed. Again, you can check using version command itself. Okay. So as you can see, I have pip installed. And suppose if you don't have, please do install it. The command is simple. All you have to do is the sudo apt install python 3 pip. That's it. Just click enter and it'll install. I'm not doing it again because I already have it installed like you guys saw. And once you've done that, to install pillow, sudo pip install pillow. That's all. And then it'll work. That's just the way of installing pillow library. Let me clear the stuff. Let's go back to program. So since we're using images, like I said, we need to use certain libraries. Here we'll be using pillow library. So if you get an error while using this program, please do install pip and pillow. So getting back to program, like I said, here we're using an image and converting that to its hexadecimal format. And similarly, while retrieving it, we're using the inverse function of it. And our secret message, which is in string format, we're converting it to binary and binary to string. And then there is encode. Basically, it goes through the hex code and places the binary bit of a secret message into the hex code. Similarly, the inverse program is decode. It'll decode the hex format. First, it'll check if for the zeros and ones, and then it pulls the data from that. So basically, we have four main functions here, which is encode, decode, hide, and retrieve. Like I said, encode and decode. Like I said earlier, it checks for the hex code, hexadecimal code, and then replaces the bits. And decode, it checks if the hex code has zeros and ones, it'll extract the data. If hex code doesn't have any zeros and one, it'll return none. So there you go. Now, these are the basic functions, and then comes the complex function, which is to hide a message. I have a hide function here. Just go through it. It's very simple. So basically, as you can see, this hide function, it takes file name and message. It opens the image library where it gives the file name as input and then converts the message from string format to binary format and adds the delimiter as we discussed in the theory part of the session so that while extracting, you know that you have reached the end of the text. So basically, first it checks if our image is in RGB format or not. If it doesn't, and then it converts to it. And then there it goes. And basically, it takes each and every bit, checks if the bit is in proper format, if the actual bit of the secret message can fit into this and all that, and then replaces the bit. And once it has encoded the secret message completely into our image, it returns a message saying completed. If the mode of the image or if your file doesn't exist, and for all that, it returns a message saying incorrect image mode, couldn't hide. Now, the retrieve function is as very simple, the most simple one. It's taking the file name from which you'll have to extract the data. If it checks first, it checks if it's in the RGA format. I mean, that's red, green, blue format. And if it's not, it's going to convert into it properly. And from there, it's going to extract the data. And then it retrieves all the zeros and ones until it finds delimiter. Once it has found the delimiter, it gets to know that it has reached the end of the text and then it displays the message success. Otherwise, it will give you an error message. Finally, we have our main function. So basically, we're going to give like string. You have switch option while writing code, right? Either in Java or C++ anyway. Just like that, I'm going to give a code. Well, it's not going to display to the user, but anyway, it's in this code according to the code. You need to use a command like Python, the file name, as in the file name and which contains the code.
-E to embed the data and the image and the text which has to be embedded and all that. Oh, we'll get to know when we actually perform the demo. So let me just summarize what we've learned in the code again. So just basically go through it. It's very simple. So like I said, we are using Pillow, a library. For that, we need to install it properly. If not, the program doesn't work. So make sure you have Python, and after that install pip, and through pip install Pillow. And like I said, we're converting our image into its hexadecimal format using this function, and inverse using this function, and our secret message to binary and binary to string. Encode, it basically checks for each and every hexadecimal of our image and replaces that by 0 or 1 of a secret message. And then you have decode. It checks if the hexadecimal code has zeros or ones. If it does, it extracts the data. Otherwise, it returns none. And then there's our hide image, which actually embeds the data into our image. So it'll take file name and message as input. It checks if the image is actually in RBF format. And before that, it converts our message into binary format and all that. And then based on certain conditions, it embeds the data properly into the image. If there is some error regarding the mode of the image you're using, or if the text file doesn't exist, it shows an error message. Same goes for the retrieval as well. It checks for the zeros and ones, extracts until it finds a delimiter, and then it gives you a success message. So there we go, guys. The program is simple. So if you guys want a copy of the code, and please do post your email ID in the comment section below, and we'll get back to you with the code. Now that you've understood the code, let's go ahead and see if this works properly. For that, I'm going to exit. Before that, like I said, I have my few images here, dogs.jpg, then cat and cube and all that. I need a text file to hide, right? So here I go. Okay, I've just typed some random message. Board meeting is on Tuesday. Please do send weapons, lawyers, and food. So I'm going to save it in my home page itself. Let me just give it a name, msg.text, and click. Let me close it. So now going back to files, as you can see, I have a file here which says msg.text. Now I'm going to use a dogs docs.jpg, the image. Oh, sorry, I forgot to tell you this program only works for PNG images, so I can't use docs image. Let's take cube.png. So Python, because we are using the Python code, I mean the file is in Python format, right? Python, and the file name is py, e to embed, and the file name, which is cube.png. Enter a message to hide. Well, basically, this doesn't actually take a file which contains the message. It directly asks you to enter the message to hide. But don't worry, the file which we just created, I'll show how to use it for while we are discussing the steganographic tools. Anyway, getting back to what we were doing, hide a message. So it says it's completed. Now let's get back to files. Now, if in case I open QPNG, it's same as before. You won't find any changes here. Getting back to terminal. If I want to extract the message, -D and enter. Success. It says the message is extracted, which is hi, send your weapons. Do you know where? So that's easy, guys. Well, it's a very simple program. It's just taking an image. Is asking you to enter the message, and it's embedding in that. So, well, you can take this as a base code and create your own code, which performs many things, or advanced steganography as well. So basically, to summarize, in this program, what we did was we converted our secret message into its binary form, and we took the bits in the binary code and replaced the least significant bits, or the blue color bits of RGB color model, by these bits of secret message. So basically, we're replacing the least significant bits so that our cover image, that's cover object, as well as a Stego object, both are same and look identical. Now let's get back to PPT. So guys, earlier we discussed about the ancient steganographic methods. There are various ways of achieving the steganography in this digital communication world. However, you do not need to perform coding to achieve this. There are various software tools are available for steganography. This software can hide your secret message behind the image file or audio file or video file or any kind of file, basically. So we are going to take a look at few such tools, and I'm going to show you how to use them, maybe at least 2 or 3. So there we go. The first tool is Stego Suite. Basically, here you can hide any kind of text inside an image. Then you have Stego Hide. It hides a secret file in an image or audio file. Then you have SIO Steganography. It's a free software where you can hide your files inside BMP images or WAV files, that's WAV files. And then there is Suite Pixel, which works as in it's similar to other tools where you can hide data and images, but the way it works is slightly different. I show you how it actually works, so don't worry about it for now. Then there's OpenPuff, where you can conceal all the files in an image, audio, or flash files. Then camouflage tools that let you hide any type of files inside any other file. So these are very few. There are other tools outside as well. As for today, we're going to explore 3 to 4 tools, which is StegoSuite, other one is StegoHide, then Steganography, and Suite Pixel. So there we go, guys. Let's begin with StegoHide. Let's go back to our Ubuntu. So this StegHide is an open source steganography software that lets you hide your secret file, an image or audio file. You will not notice any change in the image or audio file. It is a command line software. Therefore, you need to learn the command line to use this tool. And therefore, I have come back to Ubuntu here. So I've already have it installed. It's very easy to install. Apt-get install StegHide. It'll install. Use the command just sudo apt-get install StegHide and click enter. I'm not doing it. It's going to take time. Since I've already done it, I'm going to straight away use it. So StegHide. Well, as soon as you enter the command StegHide, it'll show you the help command related to the StegHide. So basically, it says the first argument should be one of the following. That is, either you should embed the data or extract the data. And you have various options that you can add in commands to use your cover object or the Stego object or your secret message. And you have options to compress and encrypt the file before actually putting it into an image for hiding it as well. And then suppose if you want entire information about your file after encrypting it, you can use different commands as well, which for example, you have info command here. If you use that command, it'll display all the information about your file. And when you're trying to embed data, it'll ask you for a passphrase. Basically, it's nothing but just like key. You can think of it as a key or a password. Basically, it's making sure that you're the right user who has entered hidden the data or extracting it. So, well, to make it easier for people using it, they also have given few examples here. So usually the command begins with StegHide, the command name, and embed to embed the file. -cf refers to your cover object. It's the name of your cover object. And then you have your secret message. And for that, you're using -ef. Let's do that. So StegHide, embed. Before that, let me go back to files. So I'm using this docs JPG and the message.txt, which we created earlier. Embed -cf. So that's docs.jpg and -ef, which is our msg.txt, right? Cool. It says enter passphrase, which let's say ABCD. It says embedding and it's done. Now to check if it's done that properly or not, let's go back to files. I'm going to move it to desktop. Click on enter. Cool. Now let's go back to desktop. Here is our file. Now to extract, I'm using extract command. Before that, I need to go to my desktop, right? Because that's where my file is stored. Here we are, and StegHide extract. SF is what you use to extract your Stego file. You can see it in the help session. And the name was docs.jpg. It's asking for the passphrase, more for security purposes. So it says extracted to message.txt. Now to check the file, you need to go back to desktop because that's where our file should be. And if you open that with editor, there you go. We have successfully extracted the data from the image. Now let's try a few other commands. Let me come back. Okay, let me try it here. StegHide. What was that? Info command, right? Info. And let's say, so as you can see, it's extracted the information about the file. It's in format, it's capacity, and it says you want to get information about the emitted data as well. Why? Could not extract any data with the data phrase because already extracted the secret message from that file. Well, if you hadn't extracted, then maybe it would have showed the embedded content as well. So that's how you use a StegHide. You have multiple other options as well. Like for example, when you were trying to embed, it asks you for the passphrase, right? Instead, if you don't want it to ask like this, you can use -p command and enter the passphrase. You can add it in the command itself here. And then it actually skips that step and actually goes back to this embedding message, a done step. So yeah, that's all about StegHide. Now let's go back to other tools. So the next tool we'll be using is a StegoSuite. It is a free steganography tool which is written in Java. And with StegoSuite, you can easily hide in confidential information and image files. So I have a file called sample here. I have certain images. It's in JPG format. It's a BMP file. And then there is a PNG file as well. So first tool that we're going to explore is StegoSuite. So there we go. This is the StegoSuite tool. It looks very simple. Basically, there's nothing here. So click on File, Open, and select the file in which you want to embed the text or the secret data. Let's go back to sample, and here I'm using this PNG image. Open. Here it's ask you for the text which you want to embed in the image. So this is the secret text I want to hide. If you want, you can give the password and embed. It says embedding completed. The file is saved to desktop sample image embed.jpg. Let's go back and check sample, and here we go. You have an image and properties. It's a JPG file. Let's try opening it. There you go, guys. It looks similar to our actual message. Well, it doesn't look different at all, but the data is actually hidden inside it, right? To know that, all you have to do is let's just rename this. Let's say image E. That's the embedded format of our image. It says the image is open. Okay, I'm gonna close Stegosuit. So yeah, you can see the image here. Let's rename it image E. Now, if you want to retrieve the message, Stegosuit file, open, select the file in which the text was embedded, which is image E, and open. Enter the password, which is and extract. So as you can see, it has extracted the text message, which earlier I hid into the image. Hey, this is a secret test I want to hide. Well, go ahead and try to use it. It's fun. It doesn't have any other functionalities apart from these. It's a very basic, simple tool. Let's go to our next tool, which is Steganography. Well, it's a free software that can be used to hide secret files in BMP, that's bitmap images, or WAV files. Use of this tool is very easy. You can just open the software, load any BMP image or WAV file to its interface, and then add a file which you want to hide. And this also supports encryption, multiple formats. Well, instead of telling all this to you, let me just show it to you. So as you can see, I have it already installed. It's just one-step installation. And to add the file, as in to encode, you need to click on this add files option. To extract, you can use this. First, let's try to add files. So the first name, all you have to do is load your BMP or WAV file. And sample, I have one BMP image. I'm gonna load it, open. Well, as you can see, this size is slightly bigger. Click on next here. So now that you've loaded your cover image, you'll have to load the image or the file which you want to store in this cover image. For that, you click on add file option here. Let's say I want to store this image. Let's try open and next. So as I said, it shows different encryption formats here. So you can select from various algorithms like RC4. Then you have triple DS, DS, triple DS with 1112 and many other formats. It's asking for the password. Give some password. Click on next. So the embedding is done. It's asking you to name the file. Let's say bird and save. So the final file is similar to the actual BMP image. You can't make out any changes, right? But there is a secret data which is hidden inside it, which is another image. Now let me close, finish. Let's try to extract it. Click on this extract files and load the source file, which should be a bird. Then open, next. It's asking for the password. So A, B, C, D, that's what I'd give it. And extract file, image2.j, save. File extract successful. Okay, finish. Let's go back to the location and see. So here we go. We had tried to store this image2 in the bird, but after that we tried to extract it. So there we go, guys. The image has been successfully extracted. This way you can store any kind of file. It can be your Excel file or Word file, document file or PowerPoint file or image or anything. So that's your Steganography tool. So like I said, you can add the files, but to extract the message, you'll have to start using this file from the beginning again. Then let's go back to our next tool, which is Izeon Pixel. It's here. Let me just check. I have installed it. I'm gonna extract all. Let's store it in our desktop. And okay. Now, if we go to desktop, this is our application, Pixel. Click on that. So guys, even this is a tool where you can store any kind of hidden information, but it has a different approach when compared to other tools. It uses image file as a key to protect your hidden text inside an image. That is, to hide and unhide text inside an image, you need to enter another image as a key. So as you can see, you have three images here: original image, that's your target image, and delta image, which acts as a key. Instead of giving some password or anything, it takes another image as a key or passphrase. So open original image. desktop. Let's go to samples. Let's try flying. Now you need to enter the message. Hi, this is the text I want to hide. And here I'm clicking on encrypt message. Save image. Let's try and save it somewhere else. Desktop. Let's store it in the documents. File name, my image, and save. Now let me open the thing again, or you can just say reset, exit here. Now if I open the application again, let's try to extract what we just hid. So open the original message, which is in desktop, right? Sample, that's flying, open, decrypt image. So there you go. So let me show it to you again. All you have to do is reset, click on the open original image, give the original image which you try to encrypt, that would be flying, and open, and then say decrypt image. So like I said, it uses an image as a key to extract or hide anything inside your image. And now give your actual image as in the encrypted encoded image or your Stego image and click on open. Yeah, and just say yes. So as you can see, it has extracted the data which I was trying to hide. So I'm sure you might have observed, right? The way it functions is slightly different from other steganographic tools, right? Sample, that's flying, open, decrypt image. So there you go. So let me show it to you again. All you have to do is reset, click on the open original image, give the original image which you try to encrypt, that would be flying, and open, and then say decrypt image. So like I said, it uses an image as a key to extract or hide anything inside your image. And now give your actual image as in the encrypted encoded image or your Stego image and click on open. Yeah, and just say yes. So as you can see, it has extracted the data which I was trying to hide. So I'm sure you might have observed, right? The way it functions is slightly different from other